The first time for this class.
It is the first time, eh?
Yes.
Okay. So I cannot see the other members. Maybe they will join later. So what is the procedure? We start off from scratch. I give you an overview.
I can only see one person here, a Kiru, so I don't know how far
There is
she has
another.
gone.
There is another person.
Yes, called a Kiru.
Oh, Kiru.
Yes.
Kiru, communicate. How are you, Kiru? Hello, hello. Kiru.
Fine.
Okay, are you also new in this particular forum?
Yes.
All right. So you are also...
Yeah, then you can give us the overview.
I give you both of you the overview.
Yes,
Okay.
yeah, from what you have and where we are currently, then now we can proceed from there. You see?
Okay.
Yeah.
Yes.
Let us embark to already have a recap of the topics that we are going to look at. The topics that are there under management accounting. Under management accounting, so today is the 10th of 2nd, 2024, advanced MA, the one that has been introduced, which you must concur with it. So the first topic, let us have the course outline, you guys. So topic number one that we'll be looking at is introduction to management accounting. Introduction to management accounting. That is the first topic that is there under our syllabus. The next topic is cost estimation and forecasting. Cost estimation and forecasting. Cost estimation and forecasting. Then after that, we go to planning and decision making. Planning and decision making, that is the third topic. Fourth topic is pricing decisions. Pricing decisions, my good students. Next one is number 5 per se is performance. Performance measurement. Performance measurement. Thereafter, we look at inventory, number 6. Inventory control. Inventory control decisions. Inventory control decisions. After that, we'll look at now number 7, budget. Budgets and budgetary. Budgets and budgetary control systems. Then lastly, we look at number 8 is emerging issues. Emerging issues. Right. So those are the topics that we'll be capturing. Are we there, my good students?
Yes.
Okay, that. So far, so good. Next one, we have already looked at topic number 2. Because topic number 1, introduction, I said I'll come to with it's just all about theories, where we were going to do what? To discuss as oral communication. So we have already tackled topic 2 partially. That is,
Okay.
we have already tackled topic number 2 partially. And at that point, I cannot hesitate to start with you topic number 2, so that we can be at par with other students.
Okay.
All right. So let's start with the topic number 2. Topic number 2, and just a minute, and we start with topic number 2. A minute in a few. Okay. Now I'm there. Now let's look at this topic number 2. Topic number 2, honorable members. So we start with the cost estimation and forecasting. Are you there? Are you there? We start.
Yes.
So, my good students, when you talk about cost estimation, these are the statistical methods that we normally use to make predictions so that we can minimize either cost in a given particular enterprise. So these costs, some of them we have encountered in this particular industry of ours, which is accounting or CPA, these costs, we can enumerate them, starting from the ones that you know, I believe, so we can list them. The first one we will start with is accounts analysis. Accounts analysis method. That is number one. Number two, I'm going to start with, I'm going to look at what we call high-low method. High-low method. Number three is regression. Regression method. Also, we normally call ordinary. Least square method. Another one that we want to look at is what we call learning curve. Learning curve, sometimes called nonlinear. Nonlinear equation. Nonlinear equation. Then lastly, we'll look at industrial engineering. Industrial engineering. Good. So those are the commonly encountered methods that we normally use to forecast.
Mwalimu,
Kiru, yes.
Yes, after staying long without doing these things, I can relate with the regression method only.
So you are confirmed with what?
Confirmed with regression model.
Regression.
Yes, others I think I've forgotten. Yeah, but it's okay.
Okay, that's why we are here.
Yeah.
Is that Nelson talking or Kiru?
Nelson.
Nelson, where are you, Kiru? Kiru, are you there? All right. So allow me to start with we start with what? With accounts analysis. Let's start with accounts analysis. So let's start with accounts analysis. So you say it is a statistical study. It is a statistical study function. It is a statistical study function. It is a statistical study function of the form y equals to a plus bx. Of the form y equals to a plus bx. Of the form y equals to a plus bx. And it classifies costs into two components. It classifies costs into two components. It classifies costs into two components, i.e., that is fixed cost and variable cost. Fixed cost and variable cost. Fixed cost and variable cost. Another point you say, if I'm too fast, you just give me a signal. Another point to say, if mixed costs are encountered in the analysis, if mixed costs are encountered in the analysis, they are ignored. They are ignored. They are ignored. Good. Let's look at an illustration. Illustration. You say, consider the following data. consider the following data, consider the following data, consider the following data for ABC Limited. For ABC Limited, for ABC Limited, consider the following data for ABC Limited, for ABC Limited, for the year ended, for the year ended, for the year ended, for the year ended 31st December 2023. 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 For an activity level, for an activity level, for an activity level, for an activity level, for an activity level of 10,000 units. For an activity level of 10,000 units. For an activity level of 10,000 units. Good. So I have details column, then you have the total cost column, figures in thousands. The first one is we have direct material. Direct material. So you can give a fictitious figure like 1 million. So that one they incurred direct material 1 million. Direct labor. Another one is direct labor. Direct labor. Direct labor. Let us give a fictitious figure again of maybe 1.2 million. Then we go to utilities. Utilities. You can have 1.5 million. But in brackets, I can say 30%. 30% fixed. 30% fixed. Then we have another one like depreciation. Are my handwriting visible?
Yes.
All right. Depreciation. We give it 700,000 for that particular equipment. Then we go to another one, administrative expenses. Administrative expenses. We give there like 900,000. Then another one called is rent. Rent and rates. Rent and rates. Rent and rates. We give like 1.8. 1.8. 1.8. That technical support. Technical support. Technical support. 600,000 in bracket 40% variable. 40% variable. 40% variable required. Then required. Required. Roman 1, a connecting equation of the form. A connecting equation of the form. A connecting equation of the form. Y equals to A plus BX. Y equals to A plus BX using accounts analysis. Using accounts analysis method. A connecting equation of the form. Y equals to A plus BX using accounts analysis method. Using accounts analysis method. That's Roman 1. Roman 2. Roman 2. Roman 2. Total cost. If total cost. If total cost. If 15,000 units. Total cost. If 15,000 units are to be produced in the following period. Total cost if 15,000 units are to be produced in the following period. In the following period. In the following period. Good. Are you there, Kiru? Next one. Is it okay?
Yes. Yes. You're okay.
Okay. Good. Now let us solve that one. Let us solve that particular question, which is very, very easy. So solution. So have 3 columns. Column 4, details. Then column 4, total, not total, but fixed cost per se. Fixed cost. And then we have variable. Variable cost. Fixed cost. And then we have a column for variable cost. So those 2 columns with respect to cost. Okay, we start. Ready?
Yes.
Let's start with the first one, which is direct material. So direct material, you are told total cost is what? And 1 million. Now, my question is, Nelson, is it fixed
Yes.
or variable? The examiner now here is very technical, testing how you can differentiate the costs. Direct material, are they variable or fixed? Because here we have not been given any variation.
Materials are fixed cost.
Direct materials, eh? Are they fixed
They are
cost or variable costs?
They are fixed cost.
No. They are variable. How? Meaning that if you have been given a contract for, let's say, for making chairs, 10,000 chairs, you will incur a given cost, maybe 1.5 million. Then another contract comes with what? With 9,000 chairs. Will the cost increase or it will decrease or be constant?
Oh, okay. It will decrease because now the number of chairs have reduced. Okay.
So that is variable.
Okay, variable, yes.
Yes, direct materials, they are variable from the word go.
Okay.
So put there under variability, that is 1 million. So there we have what? 1 million under the variable column. Direct labor cost again.
Variable.
Getting the concept because you are using 10,000 chairs producing, paying this particular manpower, but if the chairs decrease, the labor cost will decrease. So it is variable. There we have 1.2. Next one is utilities. Utilities. You have been given total is 1.5, and then you split 30% fixed. So give me the figures.
What is the first one is for 50,000?
For fixed cost.
Yes, for 50, yes.
450.
Yes.
Variable.
1,050,000.
1,040,000.
50,000.
1,050,000. Like that.
Yes. Yes.
Right. So if you add that, you come up to 1.5. Depreciation. Now again, the examiner is silent. Is the depreciation fixed or variable component?
Depreciation is fixed.
It is fixed because we normally say per annum, right?
Yes.
So that is fixed. So good. Another one is admin. Admin.
That is fixed cost.
Fixed cost.
Yes.
Okay, so fixed cost.
Administration, meaning the thing that we do on a daily basis, or
You are asking about fixed cost
the administration,
or admin?
the administration expenses.
I've not gotten you.
I'm saying
Huh?
I'm trying to classify admin expenses as fixed.
Which is correct. You see, you cannot say this, you cannot convince me saying that admin is a variable cost. Never. Administration,
Okay.
like for example, this is the receptionist,
Yes.
the cleaners, the accountants, the kitchen masters, they are being paid by that organization, not on the number of students for even it's a learning institution.
Yes.
Their salaries is what? Is constant.
Fixed. Yes. Yeah.
So you cannot pay them based on the number of students that you enroll.
Yes.
So that is what? Fixed. So we have their fixed admin 900 and a fixed component. Together.
Yes.
Rental rates.
Fixed.
Fixed. Again, 1.8. Technical support. The last one, your portion.
So this 240.
Fixed is what?
Fixed is 240,000.
Fixed is 240,000. What about variable?
That is 360,000.
360,000. Thank you very much. 360,000. Now we are done. You add, get the total, get the total, so that we can move on.
So the fixed one is 4 million.
Fixed cost, eh?
Yes.
4 million.
090.
090.
Yes.
What about the variable component?
3610.
3610. 10,000, isn't it?
Yes.
Now, after gotten those summations, we can now come here and give a connecting equation of the form y equals to a plus bx. Y equals to a plus bx with that, which will translate to A is the fixed cost. I told you it's a fixed
4,000.
4090, isn't it?
Yeah, 4090.
Plus, this is
3610 divided by 10,000, right?
perfect.
Nice.
Because we need per unit, we divide by the activity level that you are given there. So our connecting equation will be 4090,000 plus 361. I cancel that, I cancel that, I cancel this, I cancel this. Isn't it?
Yes.
So that is the connecting equation that we'll be using to forecast. Now let us forecast from 1 and 2. What would be the total cost if the company was to produce the given units? Y will be equal to mean the total cost of the company. Y stands for total cost. 90,000 plus 361. What is the activity level in the forecasted period?
15,000.
15,000.
Yes.
So do that arithmetic, you get your 2 marks. That part B normally goes for 2 marks. And that is how you are to tackle using accounts analysis.
$95,005.
Yes.
9 million.
5 million.
9 million. 9 million.
9 million.
505,000.
505,000.
Yes, 0.
Okay, good.
Yeah.
So that is how you will employ the concept of accounts analysis, where you classify costs into 2 categories, fixed and variable. Is that okay, Nelson?
That was easy.
That was it. Yes. It's just like that. There is no technical aspect there. And let's look at advantages.
Okay.
Some of the advantages.
Yes.
Number 1, you can say it is easy to understand and apply. Easy to understand and apply. Number 2, does not consume a lot of time. Does not consume a lot of time. Number 3, it relies on professional judgment. It relies on professional judgment and experience. It relies on professional judgment and experience. It relies on professional judgment and experience when separating costs into their components. 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 Are you aware of that?
Yeah.
Disadvantages. Let's look at the disadvantages.
One be that because it is historical.
Yes, it is. Sorry.
It relies on the previous information, so it's more of historical for you to get the costing.
Yeah, it is more of a historical, so that you can come up with that particular function, which will help you to forecast for futuristic purposes.
Yeah.
Correct. So let's look at these disadvantages. We can say the method is subjective. It is subjective. It is subjective since different accountants. It is subjective since different accountants. May obtain different results. May obtain different results. May obtain different results. May obtain different results when separating costs. When separating costs. When separating costs. So more in that case, you might find that my knowledge, professional knowledge and judgment may be different from another. Together, Nelson.
Yes.
Good. Another one you can say that it reliability and validity of the results. Reliability, from the word reliable. Reliability and validity of the results cannot be determined. Reliability and validity of the results cannot be determined. Good, that is it. So that's all about accounts analysis. Let's go to the next method, number 2, which is in the next method, number 2.
High-low method.
High-low method. Good. Let's look at high-low method. So you say it is a statistical, it is a statistical, it is a statistical and a hydro method. It is a statistical technique. It is a statistical technique that uses the form of y equals to a plus bx, that uses the form of y equals to a plus bx, that uses the form of y equals to a plus bx, that uses the form of y equals to a plus bx to make projections, to make projections, to make projections, to make projections. That and not. Then I'm going to say the highest values and the lowest values are determined. The highest values and the lowest values are determined. The highest values and the lowest values are determined from the independent variables. 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 i.e., that is highest. Highest x value point and lowest x value point. Highest x value point and the lowest x value point. Good. Now allow me to look at a past paper. Do you have the past paper with you? Nelson?
Admitted myself. Yeah. I'm
Your
saying
past paper.
let me get one.
Sorry?
Admitted myself. Let me see if I can get one. So we're talking about the MA. This is 2015. 2023. Yeah,
Sorry?
I've gotten the paper. I have the papers now.
From
2015, 2023.
2015 to current.
Yes.
To current, that is December, the last sitting December.
No, this is up to August.
You have up to
2023.
August.
Yes.
Okay, so that is clear. August 2023.
Yes.
So let me peruse to see the one that we can tackle under hydro method. So I have one here, November 2015. November 2015. Question number 2B. Try to accept that. November 2015. Question number 2B. November 2015. Question number 2 part B. Try to access that. If you are ready, you tell me.
Perfect. 2015 question 2.
Question 2B.
2B, yeah, the following data, right?
It reads how? Actros Limited.
Huh? No.
Actros Limited. November 2015. November 2017. Sorry,
Oh, 2017, yeah.
try to look at November 2017.
Question 2 B across Actros Limited. Yes. Limited, a subsidiary of Masterpack Limited. A packaging company is preparing a budget for the year ending 30th June 2018. With respect to the fueling consumption, the company desires to estimate the equation of Y, where Y is total expenses to an activity level X. A is a fixed cost, and B is the variable cost. The following information relates to 30th of November annual. Okay. High load in the least squares. Okay.
Good. Let's solve that without fear or favor. So let us identify. If you can see that particular columns, machine hours and the fuel expense. Which one are we going to allocate X and which one are we going to allocate Y? Because we need to get the highest X value and the lowest X value point between machine hours and fuel expense. And per se, Nelson, this setting, there was a typing error. You can see machine hours, shillings.
Then shillings. Yes, in 1,000 shillings.
That is a typing error. So you cancel that. All right?
Yes.
Yeah.
So it just become hours, huh?
Yeah, machine in hours, thousands, no problem now.
So hours become our X. Our
machine hours will be our independent value. Independent.
Yes.
Remember we say Y equals to A plus BX. This is fixed cost. This is variable cost. And this is what? Independent.
The unit. The independent, yes, independent.
Or sometimes we call predictor variable.
Yes.
And this Y is total cost or or dependent.
Oh, yeah, independent, yes. Dependent
variable.
Yes, dependent variable or total cost.
Or total cost or response variable is the same. Response variable.
Response variable. Okay.
So those names are used interchangeably. So here you must in a point to sometimes when I answer fuel expense, which is Y, and machine hours to be X. Whichever, so it is good to know which one is X and which one is Y.
Yes.
Okay. So let us identify our highest X value. What is our highest X value point? Yes.
For the 2 years, huh?
For the 2 years, yeah, for the 2 years. That is July 2016 up to what? 2017 June. So highest X value point.
It is June.
Highest X value June.
Yes.
June, which is 48 versus what? 680. That is 1 point. The next point, lowest. Lowest X value.
So the lowest here is
There are two.
February.
February and January, I can see that tie.
Yeah.
There is a tie.
Tying here. There's a tie there. And
So,
even the okay.
So meaning that we have 26 versus 500, and again that is January, February. Again, 26 versus what? 500. Right?
Yeah.
So in that case, you can take any. So what if I was asked that question, the one I'm asking you in a certain institution, what if we have 26, but when it comes to the y, here we have 570. Which one will we go with? Using this lowest.
I'll pick the first 26.
26, yeah? If that is the case, if there is the independent day of time, you go back to y and take the lowest.
Yes.
Because we are after the lowest. So if the x are tied, you go to y, take the lowest, which is 26,500 together.
Yeah.
So okay. But this one of ours, there is no tie. So we have that one. Now let us have the equation using y equals to a plus bh. Let's plug these figures to this particular link.
Okay.
Total cost, the first one, 680 equals to A unknown plus B unknown, but units I have 48 together.
Yes.
That is equation number 1. Equation number 2. Equation number 2. We have 500 being equal to A plus 26B. Equation 2.
Nice.
So I can see we have what? Simultaneous equations.
Yes, yeah.
Under QA, we learned about simultaneous equations. So there are methods. We have what? Elimination and substitution. But when it comes to here, like in this case, look at A. Coefficient of A is 1, 1. So I can eliminate that by subtract.
Yes.
Direct, I subtract.
Oh yeah, true.
So that I degenerate A. So 68 minus 500. I hope you have the calculator, the powerful machines.
That is 180.
180, good, 180 equals to A has degenerated 48 minus 26.
22.
22 B. What is B? You divide both sides by 22.
This is 8.18.
8.18, perfect. Substitute in any of the equation. Let us go either equation 1 or 2. Let us substitute in equation 1. 680 equals to A unknown plus 48 into 8.18.
Just a few. Robert.
Sorry? Hello? So substitute that and get the value of A. Kilo, where is kilo? Nelson, are you there?
Yes, mwalimu kidogo tu nisaidie mtu.
Okay, perfect. Does not require a lot of data. That is the second advantage. Apart from tumesema ya kwanza, method is simple to use and apply. Number 2 doesn't require a lot of data. Disadvantages.
Yes.
It does not incorporate or capture all the observations. Does not incorporate all the observations. Does not incorporate all the observations.
That's an advantage for the least square.
Sorry,
sorry? So that will be the advantage of the least square on that side.
Yeah. Does not incorporate all the observable data or all the observations. Number two, the reliability and the validity of the results cannot be evaluated. Reliability and the validity of the results cannot be evaluated. Reliability and the validity of the results cannot be evaluated. Disadvantages. Oh, we are under disadvantages, isn't it?
Yes.
The next one you can use, you can say there, it uses extreme values. It uses extreme values. Uses extreme values, which may not be a good representative. Which may not be a good representative. Which may not be a good representative. Which may not be a good representative of the other values, of the other values, of the other values. So that is all about high-low method. We together?
Mwalimu, yes, on number 2, reliability and validity cannot be evaluated. Now, if you look at monitoring and evaluation, which is the current concept that happens almost in every organization, that they are now trying to do monitoring and evaluation of the projects. So, in explaining this point, will it be as much as we cannot evaluate it immediately, but it can be that we can maybe rephrase and say it will take a lot of time for monitoring and evaluation to see the effect or the reliability of the same.
Yeah, I get you.
Yeah, because again, we do it for this year, then try it for the next year and see how it works. So it will take us 1 year to know whether we were right or wrong.
Yeah.
Yes.
Good.
Okay.
So up to that point, we can. By the way, this question was again repeated. And I'll show you how it will be. The year that was repeated currently. I think it was May 20. Let me see. What's repeated? I get it. Try to look at May 2021. It was just a bit of copy paste. May question 2. May 2021. May 2021. Question 2. A. Try to look at it.
Actros, the same wording. So the same thing, right?
Yeah, even the figures. But they changed the year. Here we are talking about 2020 up to 20.
Yeah, the same thing.
Yeah, yes, you can see.
Same question. Wow. Okay.
So that's how KASNEB is.
Ilianza lini? Sawa.
Right. So let's look at Roman 3 of the same paper. Not Roman 3, but part C. Let's look at
the one for 2017, eh?
Yeah, for 2017. It's an element of part C. Let us try to look at it. So for part C, they are saying that from the information in B above, the coefficient of determination arising is approximately 0.25. Interpret the significance of this information.
Can I try?
Sorry?
Can I try?
Try.
That is the 0.25 is the big R, right? So it means that the 25%.
It is not
of our
point of correction. It is not R. Coefficient of determination is R squared.
Yes, R squared, yes. So what it means is that 25% of our total cost, yeah, can be explained by the machine hours.
Perfect.
So mean the remaining 75% of our costs would be other factors not included in this calculation.
Yes, like
right?
what?
Yes. Like now we have other things. What are we producing here?
We are producing
Like we
labor.
have even now, if you look at even those people that we are working with, the labor that we have. So the labor can be a problem in that we don't have the skills, the efficiency of the skills.
But in this equation, we are not including labor.
Yes, but explain me. I'm trying to say the remaining 75% can be a result of labor efficiency.
Like labor.
Yes. Yes, I will think.
Inflation,
Yeah.
taxes. Those are other factors not included in that particular model, isn't it?
Just a few.
Those are the, you are saying, you are correct as you are saying that 25% of the total cost, okay, fuel expense has been explained by machine hours, isn't it?
Yes.
And then 75% like labor hours, machine hours, inflation, taxes have not been included. So therefore, they are the error or the residue, which we have not captured for prediction purposes, isn't it?
Yes.
That is the concept. I can see you have the good concept there. So that is what we were trying to figure out. So in this case, the model is what? The model is not significant because it is giving the lowest percentage, isn't it?
Yes.
Yeah. So the model is not significant. Good. So that is what we were required to look at coefficient of determination. Up to that, we go to the next method, which is what?
The least square.
Least square.
Yes.
Cut. Least square. Least square equation. Least square equation. And just a minute. Yes, I'm there. So let's look at that particular forecasting equation. You say it is a statistical technique. Are you there, Anderson? Are you there, Nelson?
Yes, I'm here.
So we say it is a statistical technique. It is a statistical technique. It is a statistical technique. It is a statistical technique that forms an equation of the form, y equals to a plus bx. Y equals to a plus bx. Y equals to a plus bx. Another point we say, if the values of a and b can be determined, if the values of a and b can be determined, if the values of a and b can be determined, the equation will be complete for prediction purposes. The equation will be complete for prediction purposes. The equation will be complete for prediction purposes. Therefore, they are determined as follows. So we start with B, which we get as N summation of xy minus summation x, summation y, everything is divided by n summation x squared minus summation x into bracket squared. For B, that is how you get. For A, it is summation of y minus b summation of x divided by n. We together what are the more members?
Yes.
So that's how you get the values of A and B, so that the equation can be complete for prediction purposes. Now we look at that question, which is November, the one we were looking at, November 2017. Now we tackle Roman 2 using least squares method.
Now for A is equal to summation of y plus minus B.
The one you have got.
This is B, eh? Oh, okay. Over n. Okay. Why can't KASNEB allow us to use Excel for these things?
Sorry?
KASNEB mbona ituruhusu tumia Excel kwa hizi vitu? For example.
BDA. You know there is a third paper for BDA.
Business analysis.
Business analytics.
Yes, I want to make Excel, eh?
They are using Excel, that project.
Okay.
Yeah.
Sawa.
Ukifika hapo sasa utatumia BDA, hiyo business data analytics. Unatumia kwa laptop and the app of advanced Excel.
Yes.
Good.
Okay.
So in that case, you'll compute those particular summations as they are there. So meaning that you'll have the column for machine. You have the column for machine, and we have the column for fuel expense. Then we have here machine, fuel expense. So this is x, variable x, and this is variable y. And after we will have what x, y, and then x squared. Are we together?
Yes.
And so you have two columns, eh? Two columns for x and y and x squared. That. So you are going to enumerate those particular amounts. So the first one is 34, 30, 34, 39, 42, 32, 26, 26, 31, 35, 43, and the last three, 48. The same case on the field, you have there 64, 62, 64, 640, 640, 620, 620, 590, 500, 530, 590, 500, 530, 500, 500, 530, 550, 550, 580, and then 680. So you need to do that computation. You get the summations for those four columns. But remember, Nelson, there's a way you can,
Yes.
because you are advanced, there's a way you can use calculator, scientific, yeah?
Yes.
You know that process?
I know you have to key in values. I've done it before, but since I started using Excel, I forgot. But now, for exam, sasa for exams, you have to show you are working.
Sorry?
I'm saying, in the calculator,
Uh-huh.
I was doing it before until I started using Excel, so I left calculator alone.
Okay.
but now I'll have to learn again. But again, I'm asking for example, process lazima tuweke uonyeshe all workings for exams ama.
For exam, ukishaandika hivyo, you show the out to get B, you show the formula. Then you plug the figures, summations to that particular formula.
Okay.
And if you are using the calculator, there is a way you can generate the particular variables A and B directly from the calculator.
Si tufanye hiyo.
Oh, your calculator?
Yes. Niko na ile scientific.
You have the scientific?
Yes.
All right. So,
ama nakutafuta baadaye.
but I can give you the process, eh?
Yes, yeah, I think that will be better.
So that calculator, ensure that the calculator is set into regression mode, meaning that for your button more clear, you have to clear, you clear first of all everything in the calculator. Shift, there is that mode for clear. Are you able to see that?
I have shift clear, yeah, clear is nine, eh?
Then shift clear,
so
then reset, number 3.
Okay, shift clear.
Shift mode. Button for mode.
Okay, so there is shift kwanza, then clear. So I choose. Huh?
Which calculator FX?
82 ES plus.
FX 82.
Yes, ES. So what I've done, shift then clear.
Reset.
Then ikaniambia clear setup, memory,
number 3,
or all.
Yeah.
So I clear all, right?
So the computer is what? Is clear.
Okay.
Now let us now reset.
Yeah, so reset nasema yes.
Mode. Regression imekuja icons.
Okay, so I've reset all. Press AC key. Okay, so now I've reset. I'm not done the clearing. So number 2, I go to mode, right?
Mode.
Then I have got the comp, start, and table.
Under mode, you will have what?
Yes.
We have the regression. Comp regression, then
no. Mode. Sasa kwa yangu yangu sasa iko hivi, yangu iko na comp number 1, number 2 start, and number 3 is a table. So I will, so if I do start number 2, inaletea mambo ya variance A plus BX hizo.
No.
Okay, what we do, acha tuendelee na hii safari tumalize hii hesabu, then we can now, I think, can catch up later. Tumalize hii.
Sorry?
Yeah. So,
sorry?
I'm saying let's just continue doing whatever we're doing, then you'll teach me this one later.
Okay.
Yeah, don't waste time on this.
Try to get those, you can do that now manually to fill the tables.
Yeah, this one's can be done manually.
The submission will proceed. After you are done with those submissions, all of them, you just give a signal. I'm here.
Okay. Yes, and proceed.
Good. So up to that, you can now give our summations to this particular gradient. So B will be, N is what? N is 12 months, right? Count them, 1.
Yeah, they are 12. They are 12.
That is N. Times summation of XY. Column
241, 670.
Yes.
241, 670.
Minus summation of X. First column.
The summation of X is 420.
420. What about Y?
6840.
6840.
Yes.
Divide by 12 again. Summation of X squared, the last column.
X squared is 15 to 12.
Minus 420 squared. So at that point, you can simplify, get the value of B. The same case you do with the value of A, so that our equation will be complete.
Okay. .43.
4.43. That is it. What about the summation for the B? It's not B, but A. Try to get A. Summation of Y minus B. Summation of X divided by N. Summation of Y. Summation of Y is 6840, if I'm not wrong, minus 4.43.
So A is for 14.82.
Yes,
For 14.82.
that is the last one, that is the end result.
Yes.
414.
Yes.
414.82.
82.
Correct. So therefore, our cost connecting equation would be 414.82 plus 4.43, 4.43x. That is the connecting equation using least squares method.
Just an example, if X was supposed to be 100, from the two methods, just to see.
Yeah, for the two methods, to see which method is better.
If they are far away from each other.
Sorry?
Just want to see if there's that much difference.
Yeah, if there is any difference.
Yeah.
Just try to figure out.
Difference of 248 shillings.
Difference of
248 shillings.
248.
Yes.
Okay. So at any point
Not far.
at any point in time, which
Yes.
method is better?
The method is the least square.
The least square is the better.
Yeah, because you are having a lot of data points. We're using all observations.
We are using all the observable data.
Yes. Yeah.
Yes, that is it. Advantages of regression analysis. One, objectively determined. One is objectively determined. Objectively determined. Objectively determined. Number two, makes use of all the data available. 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 Number three, it gives accurate predictions. It gives accurate predictions within the relevant range. Within the relevant range. Within the relevant range. Those are the ones that you can give. They may ask you 2 or 3. These are advantages. Disadvantages. Number one is it assumes that the relationship between dependent and independent is linear. Assumes that the relationship between dependent and independent variables is linear. Assumes that the relationship between dependent and independent variables is linear. Number two, regression assumes certainty of some parameters. Regression assumes certainty of some parameters. Regression assumes certainty of some parameters. We there?
Yes.
So those are what we call the disadvantages. So up to that juncture, we are done with the regression. The next one is what method of forecasting?
The learning curve, nonlinear.
Learning curve, nonlinear.
Nonlinear.
Yes.
Yeah.
Nonlinear. That is a learning curve. Well, that is under CPA, as I have taught, that is the one that has been added. Because under intermediate, MA intermediate, we have industrial engineering, accounts analysis, high-low method, least square. Those are the ones that we encounter, and the ones that I teach under MA intermediate. When it comes to advanced, we include learning curve. So learning curve is the one that is being included in that particular forum. So just tuache pate break kidogo, then we kuja tuangalie hiyo learning curve because that is a new concept. We need to, it's a highly examinable. We together?
It looks like it's more of exponential, huh?
No, it is not exponential.
Oh, so
It is not exponential.
hi.
So
So,
break of a few minutes, then we come back.
how many minutes?
Like let's have of 20 minutes. If we start at this is 3:45 of
4.
Sorry, 4.
We come back at 4.
Okay, thank you.
So,
And our lesson is ending at 5.
at 5.
Yeah, we have 3 hours. It is a 3 hours lesson. Were you told?
Yes, I was told it was a 4 hours lesson.
4. 4.
Well,
4,
but it's
no.
okay.
We because in fact from another lesson from another college.
Yes.
We need to go for 4 hours. That is, I will be exhausted fully.
Okay. No
So
worries.
the capture is that we are doing for 3 hours, and then tomorrow is Sunday.
If tomorrow is Sunday.
We are meeting at
from 4 to 6, eh?
No,
4.
Sorry.
Kwa delivery ni 4 to 6.
You'll be communicated by the admin. I believe it is from 6 to 8.
6 to 8 is there's audit class. So things have changed. Okay.
They shall communicate once I'm through with this, I'll communicate with him so that tuongee kwa group hapo.
Okay. Sawa.
So that kesho nakuja for 2 hours.
Okay, sawa. Hello?
Yes, Nelson, are you there? Nelson,
Yes.
we start. So let's look at this concept of learning curve. So the concept behind learning curve is that when somebody is introduced to a particular job for the first time, he has no or she has no experience, one. Two, he or she doesn't have what? Confidence in that particular job, which is repetitive in nature. So that
Your
means,
network is a bit
yes,
problematic.
yes,
I'm saying your network is not clear now. It's breaking.
network's not clear.
Yeah, you are breaking.
I'm breaking. Am I audible? Am I audible? Am I audible?
Yes.
Okay, now I was saying the concept under learning curve is that when an individual is introduced to a particular job for the first time, which is repetitive in nature, he doesn't have knowledge, he doesn't have experience and confidence in that particular job. Therefore, the time that he will take to produce the first unit will be higher compared to the subsequent units, second unit, third unit. So for example, if he's building or manufacturing a particular table, it may take 5 hours for the first time. Second table, third table, time will reduce because at that juncture, he has gained experience, he has gained confidence in that particular job. Therefore, time will reduce as more units are being produced. And then the concept that for that part, it is drawn like this. So here we have time, and here we have time and we have units. So time will reduce because of experience and confidence as units decreases and increases.
Ceteris paribus, right?
Sorry,
Ceteris paribus.
I'm not getting.
Other factors held constant.
Yes, the ceteris paribus. So the curve will at that point, it is what? It is parallel. It reaches a point where the curve is parallel to the x-axis. That is the point of stabilization, whereby that particular individual now, he has the constant time to produce that particular job. If it is now veteran, he will take constant time at that point before he reaches what? The steady state or equilibrium. Getting that point?
Yes.
Under the learning curve. You see, it is nonlinear. It is nonlinear as opposed to the ones that we normally call linear. Linear, as one variable increases, the other one also increases, but this is nonlinear. That is the concept here. Now, at that point, we can look at some of the small notes here. We write, let us write. When a task is manual and repetitive in nature, when a task is manual and repetitive in nature, and performed by the same individual, 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 it has to be observed that, it has to be observed that, it has to be observed that, it has to be observed that subsequent jobs will take lesser time. 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 On average, on average, on average, on average, than earlier jobs, than earlier jobs, than earlier jobs. This is as a result of experience gained. This is as a result of experience gained and confidence attained. Experience gained and confidence attained. Experience gained and confidence attained. And confidence attained. That is it. Then let's look at the concept heading, concept of learning curve. Concept of learning curve. Are we there?
Yes.
You say learning curve portrays the relationship which is inversely proportional. Learning curve portrays the relationship which is inversely proportional, which is inversely proportional. Therefore, as output increases, more experience is gained, 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 and the average time for producing subsequent units decreases, and the average time for producing subsequent units decreases, and the average time for producing subsequent units decreases, decreases, decreases. And at that point, by the way, I believe that is where I stopped with the other individuals. That is where I stopped. We looked at some of the questions regarding this learning curve, like 4 of them or 3, if I'm not wrong. Now let's look at learning curve models. Learning curve models. So one is total time model. Total time model. Total time model. Total time model. Then you say it is a model that is used to determine. It is a model that is used to determine. It is a model that is used to determine. It is a model that is used to determine the total or cost of a product. The total or cost of a product, the total or cost of a product. Total cost or total time of a product. Total cost or total time of a product. Then so that in that point we say y equals to a x raised to b plus 1. And in the total time model, y equals to a plus x raised to b plus 1 per se. Ax raised to b plus 1. Ax raised to b plus 1. Ax raised to b plus 1. Then number 2, average time model. Average time model. Average time model. Average time model. You say it is a model that is used to determine the average cost or time. It is the model that is used to determine the average cost or time model. Are we there?
Yes.
So you say where the model is that the model of average, it is like this, y bar being average. Ax raised to b. Ax raised to b. Ax raised to b. Where y total time model, where y total time of that, where y is the total time. So we are saying y is the total time. Total time. Y is the total time. Then y bar is the average. Average time. Average time. A, time taken to produce. Time taken to produce.
First unit.
First unit. Time taken to produce the first unit. Then B, this is the learning index. Learning index. B is the learning index. B is the learning index. Learning index. And then X is the output level. X is the output level. X is the output level. Output level. Good. And how do we get now this particular learning index? So learning index, let's see how now to get the learning index. So to get that B, which is the learning index, we normally say it is log of learning rate. Log of learning rate. Learning rate. Sometimes called improvement. Improvement rate divided by log 2. So we know that we are not equal. We have fast learners, we have remedial, and we have slow learners. So if the improvement rate, for example, it is 90%, that means the learning rate for those employees in that particular industry, it is what? It is very high. So at all times, you must be given by the examiner the improvement rate or the learning rate. So you can be told to use 90% or 85% or 95%, whichever, even 75%. So that is the point. You get what? The learning index. Learning rate over log 2. Log of learning rate divided by log 2. Are we together? Are we together, Nelson and the company?
I think I'm only here alone.
You are alone. Where
Yes.
is the other guy? He
Yeah,
left.
man,
Go. Kiru.
I think I'll talk.
Alitoroka.
Mm.
Sawa. So that is all about the introduction of learning rate. Now allow me to look at a question. We look at some of the questions from our past paper. From our past paper, we look at some of the equations. Now, let's look at this particular question, May 2016, question number 1C. Try to accept that.
May 2016.
Question 1, part C. If you are there, you just inform me.
Only 6 marks, huh? Spacecom.
Yes.
Okay.
So you are told there, this is May 2016, question number 1, part C. So you are told May Spacecom Limited is about to bid on a new radar system. Although the product uses new technology, Spacecom Limited believes that a learning rate of 75% is appropriate. The first unit is expected to consume 700 hours, and the contract is for 40 units. Contract is for 40 units. Required from 1, the total amount of hours required to build the 40 units. From 2, the average time to build each of the 40 units. Then Roman 3, assuming that a worker works 28 hours per year, determine the number of workers that should be assigned to this contract to complete it in a year. So learning curve. So meaning that the time taken to produce the first unit in respect to this particular bid will not be the same as the time to produce the 5th, the 10th, even whatsoever, even the 40th. Which we said the time will be what? Will be reducing because of experience and confidence. So let's start with the first one. We're starting the total time. So here on 1, total time for 40 units. Our model, it is x raised to b plus 1. Ax raised to b plus 1. So we start with getting this learning index, the learning index. So b will be gotten by log of the learning rate in respect to log of 2. I say that partially log of 0.75 divided by log 2. That one will give us from your calculator. You just pump logarithm of 0.75 divide. You use the word divide. Divide by log of 2. There is that pattern for logarithm. So try to access that.
Negative 0.415.
0.415.
Is it a negative?
No. Yeah, it is negative.
It's negative, right? Yes.
Logarithm of 0.75 divided by log 2 equal sign, giving us negative.
Negative 0.41442. 0.42. 42.
0.442.
2. I'm not working in 4 decimal. Okay, the 150.
0.
4 significant. 4.150.
4.150.
50.
All right.
Yes.
So what is now b plus 1? Add 1. Add 1 to that particular figure in the screen.
0.585.
So therefore, time for 40 units. Total time for 40 units will be equal to A is the time taken to produce the first unit. Time taken to produce the first unit. You are told to be
700.
700
Yes.
into 40 units, the one that we are being told, raised to 0.585. So what is that time for 40 units in lump sum that I will be checking?
Okay.
You start with bracket 40 in bracket raised to that figure, then what you get, you multiply with 700.
6,000. 6,057.64.
6,000.
6,057. 6057.
650.
57.64.
Like that. 67 hours, eh?
Yes.
All right, so that is Roman 1. We get the 2 marks. We get the 2 marks for Roman 1. For Roman 2.
The average.
Average. Y bar A x raised to b. So that is how we get the average using the model. So let us have the figures. So it will be equal to 40 into, not 40, 700 A. 700 into 40 raised to negative 0. B alone, it is negative 0.415.
151.
151.
151 hours, yes.
151 hours. So Nelson, my good students, what if you use the literal method? Or the general method? Average time.
Okay. We take
I'll take 60, 57. So that is the total time in lump sum for the 40 units.
yes.
I divide by the number of units, which is 40. Is it giving us the
Yes.
same? It must.
And the same.
Yes, that is it. That is it. So you can use the method, which the average method, or you can use just either of that particular general method.
Which will give marks?
Yes?
Which will give marks?
Which one?
Masking.
Uh-huh.
Which one will KASNEB be looking at? Will they be looking at the first one or the second formula?
Both of them.
Both of them, okay. So you can use any. Ukisahau hiyo juu unatumia ingine ya kawaida.
Yeah.
Okay, sawa.
Let's try now the Roman 3. That is now the general. That's the application. Try that Roman 3 for me. Just give a try.
They're just 3 workers.
Sorry?
Averagely 3 workers. It's about the 60, 57 divided by 2080.
Perfect. That is.
This 2.9, that is 3 people.
Okay, so we are saying this is averagely 3 workers. That as you have done it, is averagely 3 workers. Good. Now allow me to look at another. I give you another example. So you say consider the following data. A 500 hours. Learning rate 90%. Required. Roman 1. Total time to produce 48 units. Total time to produce 48 units. Good. Roman 2. Average time to produce 48 units. average time to produce 48 units. Roman 3. Total time to produce 11 to 25 units. Total time to produce 11 to 25 units.
45.
25.
Okay.
Right?
Yes.
Then Roman 4. Average time to produce 11 to 25 units. Average time to produce 11 to 25 units. 11 to 25 units. 11 to 25 units. Then Roman number 5, that is 5. Time taken to produce 30-second unit. Total time to produce 30-second unit. Total time to produce 30-second unit. Good. Now, lesson. I think Roman 1, Roman 2, you can do for me.
Yeah.
Do that, so that we can see whether you are getting that concept, so that we start in Roman 3. Do that one, and then you give me a signal.
Done.
Okay, you are done. That is it. So,
Yeah.
how many hours for Roman 1?
Yeah, that is 13, 325 hours.
13.
Yes.
13.
3. 325.
13,325.
Yes.
Average
277.6 hours.
277.
Yes, just it 0.6 hours. Yeah.
277.6 hours.
Yes.
Now, Roman 3. Where my concern is Roman 3. So now Roman 3, you are being told to get the total time to produce 11 to 25. So that means I'll take, so what total time for 11 to 25 will be equal to
5 and 5
take the total time for 25 minus what?
minus 5, 11.
Minus
Y for 11.
minus 11
Yes.
minus 10. I need 11 to 25. The 11th one is inclusive in my analysis.
Okay.
Are you
Yeah,
getting
for
the
the
concept?
25 years. Yeah.
Are we together?
Yes.
So it is 25 minus 10. So do them. What will be now the total time at that point? Go ahead. I'll give you the concept. Sasa bit kabisa uko hivyo oh
4140.
yes, sorry. There was another teacher who is coming in for advanced FR.
So the
Okay.
answer here is 4140.
Umepata ngapi?
4140 between Y25 to Y10.
How many hours?
4140.
4140 hours. Those are the ones that they are being consumed when they produce from 11 to 25. Roman number 4. Average time. Now, my good student, if you use the method, the average method, you'll get negative hours. Try. Use the method. So here we have y bar, which is we take what we get 11 to 25. It will be, that is the same. You can say you can take y 25 minus y bar 10. What will be that? What will be the hours there? Try to compute that. so that we can give the reason in that particular aspect.
Minus 45.
Yeah, minus
45.8.
negative 45.81
81. Yeah.
hours. And you mark you, we cannot have negative hours, isn't it?
Yes.
So that one declines, degenerates. In that case, we use the general method. General method, in that case, we can say, therefore, y bar 11 to 25, we take total time for 25 to, and then I minus total time for 10, divided by, what is the difference in terms of units? 25 minus
15.
10.
15.
15. That is how you determine the average when we have what? Cumulative production. Cumulative production. You cannot be able to use the method of what? Average method. It is only used when we have what? When we have lump sum. Lump sum units, but not cumulative. Getting the point?
Yes. And now the answer is almost equal to the one that we have above there for the lump sum.
Which one?
277 in 2, Roman 2.
Yeah.
Which is okay, right? Which is okay.
We can use it. We can use that the average time model to determine this lump sum, isn't it?
Yeah.
That is the point. We can use that particular average time model. But if you have this particular range cumulatively, you use the general method or literal knowledge. Getting that?
Yes. And I'm saying the answer here in 4 is similar to that of 2.
Or this one.
Yes.
If you take the average time from 11 to 25.
Yes.
It is this one.
Yes. Actually 276, just a difference of 1 point.
Okay, so that's just a coincidence. So it is what?
276.
276
Yes.
hours. So that is just a coincidence in that particular scenario. Together?
Yeah.
Now, the last one is time, total time, total time, total time for 30-second units. Total time for 30-second unit. Try to give a try. How will you tackle that? Give a try.
Produce 30-second unit. That will be time to produce 32 minus producing 31.
Perfect. Correct. Very much appreciated. So it is total time for 32 units minus total time for 31. So that we get that particular 1 unit at the 30-second. So some students were saying, why not 32 minus 33 or 33 minus 32?
Now that one they are going to do the 1.3.
At this point, we have reached up to what? We have produced up to 32 units. Now we want to determine that particular unit at the 30-second, only 1. So we take the 32 minus the previous, which is 31. We get that particular 1 unit. Getting that?
50.97 hours.
Yes. Answer coming to
250.
So in that case, you'll have, what was the total time? You got 500
500
into 32 raised to point
0.848.
48 minus 31. That is the summary raised to 0.8848. Yes, like that. You can summarize because of, instead of doing individually, you can summarize 5. That is the shortest way. Then to be to
Answer is 251 hours. 251 hours.
51 hours. Like that.
251.
Yeah, sorry.
251. 251.
Okay, thank you very much.
Yes.
All right. So I've given you some of the clues that you'll be required to meet in the exam scenario. So let me try to give you an assignment. You will try for me November 2018, question number 5. So assignment, November 2018, question 5.
Okay.
That is
November 2018.
question 5, part C. Question 5C. So try that. Then another one.
The unit cost.
Sorry.
Wameamua complicate, eh? So another one.
Another one is May 2015. Question number 2. Question number 2. May 2015. Question number 2A. May 2015. Question number 2A. Are we together?
Yes.
So you said your papers ranges from 2015 to?
From 2015, it was 2015 to 2023.
Okay. Now try those. You try those two. You try those two. I have another one here for December 2014. But since you don't have that one, try those two first of all.
Just a few. You've said May 2015.
Yeah.
No, I don't have May 2015.
Sorry?
I don't have May 2015.
You don't have May?
Yes, he means September.
Or September. But you give me a November.
Yeah, see what we do, I drop you my contact here. You can now do me a screenshot of the same. Mapicha ya hiyo swali.
All right. Yeah. Yes, yeah, I give you mine so that you can call me 07.
Okay. Sawa.
So at that juncture, we stop there, Nelson, and thanks for your time.
Okay.
So let's meet tomorrow.
Tomorrow.
Tomorrow is from 6 there.
Okay.
All right. Bye.
I see you. Thanks.
All right.